So in this sequence, I'm going to give you a quick demo of a couple of feature engineering examples. And they're very simple, and we're just scratching the surface. It's a vast area, and there are many, many feature engineering methods that are used. We're just going to talk about two. One is aggregating categories, that's a very important one, and the other is transforming a variable, which is, again, a very important one. So we'll just go through those two super important cases. So on the screen here, I have some code, and we're just, recall when we did the visualization, the number of cylinders had some odd characteristics. So let's just build a frequency table here and remind ourselves of that. Well, the problem is that most cars out of our 195 in the sample have 155 out of 195 have 4 cylinders. A few have 6. A surprising number have 5 cylinders. But we only have 4 8-cylinder cars, 1 3-cylinder car, and 1 12-cylinder car. So what we need to do, and these categories have so few members, the 8, 3, 12, that they're really a problem. And we saw from the range of values that 12 and 8-cylinder cars had very similar characteristics, and 3 and 4-cylinder cars had very similar characteristics, as did 6 and 5-cylinder cars. So what we're going to do is a little trick here. We're going to build a dictionary. So 3-cylinder cars get put into a new category called 3-4. 4-cylinder cars get put into a new category called 3-4. 5-cylinder cars go into the category 5-6. 6-cylinder cars, 5-6. 8s go into 8-12, and 12 goes into 8-12. So by building a little dictionary like this, we can then run a list comprehension over the original categories, and we'll get them mapped to the others, and we'll just do value counts on those. So now we have 156, so we added 1 to our 3-4 category compared to the 4s. We have 34 5-6s, which is a little bit more promising. We still only have 5, 8, and 12-cylinder cars, so that's still a bit of an issue. But they probably have different behavior. So we don't want to go you don't want to go further with this than makes sense in the nature of the data. But you definitely want to aggregate as many categories that have few members as makes sense within the domain that you're working in. So let's just do a box plot, and we can look at those results. How do these prices change? And actually, so remember, price is the label, and now we have these new categories for number of cylinders, and there's actually quite a bit of separation by these new categories. So I think that's a very successful piece of feature engineering, because we've gone from categories that were almost meaningless, like 1 3-cylinder car and 1 12-cylinder car, to 3 new categories that seem to be well separated by price, which is what we're trying to predict. So let's look at another common approach for, now we'll look at a numeric variable, which is, and we're going to look at whether we should transform that or not. And in this case, we're going to look at just price. Price is, of course, a very important variable. That's our label, as I said. And price, as we had already noticed, is strongly right skewed. It has this long tail out to the right, and a big mode here at the low-priced cars. So the transformation here is fairly simple. We can use the NumPy log method on that column and create a new column in our auto price data frame called log underbar prices. And we'll just make the density plot and histogram of that. And okay, so here's the original. Here's the transformed values. It's definitely more symmetric. It's still got significant right skew, but it's not as extreme. So I'd say that is a better behaved label in general, because it is a bit more symmetric. And so we're kind of liking that. So that's just a really basic transformation. We could try others. We could try square roots or squares or something like that and see if we got anywhere. So those are just some really simple feature engineering methods, aggregating columns so that they make sense for the domain, and doing some sort of numeric transformation on some variable.